A large model Showman'S engine, part 70. The water gauge protector nears completion by drilling and tapping the 4 uprights. On screen currently are the 2 support brackets. I've marked them out ready for drilling a hole in each corner of both of them. I didn't really need to do this. It would have been a much better idea to use a small amount of Loctite 603 to hold the gland nuts in position. Alternatively, I could have turned a piece of bar to fit in the holes in the centre of these 2 blocks. Then I could hold the entire assembly in my rotary table, which would make the positions of the holes incredibly accurate. And why didn't I do it that way? Well, a lot of people do not have rotary tables, so it's no good showing a method that is specific to the equipment that I have. I simply drilled a hole on each of the lines the same distance from the edge. How was I so sure that the holes were going to be in the right position? I started by clamping the brass block in the machine vise on my drilling machine. Then I drilled the first hole on one of the lines. I then removed the brass block from the machine vise, refitted it at 90 degrees and drilled another hole on the second line. After drilling 4 holes, which are all in the right place, I thought it would be a good idea to transfer these holes onto the other block. I held both of the blocks together using the twist drill that had drilled the holes with in the first place. Then I used a very sharp pointy needle file to mark the positions through the holes. After this, I drilled the 4 holes in the second brass block, and as you can see, the holes lined up very well. The 6BA bolts were quite a tight fit in each of the holes, which is what I wanted, because I drilled them at tight clearance size. Doing it this way would not be accurate enough for a lot of engineers, but it's near enough for rock and roll and it's good enough for me. After all, I am not building an orbital satellite or a space rocket. These brass blocks are for a water gauge fitting on a model steam engine. You may have noticed that I've rounded the edges of the brass blocks and cleaned them up on my belt sander. The finish is far better than the commercial gauge. Not perfect, but things in life seldom are. It's all a matter of degrees. The manufacturer of the original water gauge was obviously happy with this. Personally, I could not have left it in this condition. I spent quite a lot of time thinking about the best way to mount the 4 brass rods on these 2 pieces of brass. At this moment in time, I do not want to cut the brass rods. I will need to fit the water gauge to the engine with the 2 brass blocks in place. And after tightening the gland nuts to seal any water leaks, I'll need to measure between the 2 brass blocks. At this stage, I'm going to cut the brass rods longer than they need to be. But once the gauge is fitted to the engine, I will know exactly how long I need to make these rods. I cut the rods oversize using my bandsaws shown here. Once I got 4 long brass rods, I fitted each of them in turn in the chuck of my Myford ML7R lathe. I made a video a while back about repairing the paintwork on this Myford. Can you spot the repair? What I'm doing at the moment is facing across the front of every one of these pieces of brass, but only at one end. This is immediately followed by using a small centre drill to drill a hole in the centre. This clip shows a tapping size drill for 6BA. I'm purposely going to tap this hole much deeper than it needs to be. That way I'll be able to use a taper tap instead of a plug tap, and there's less chance of it breaking. I want the drilled holes to be the same length in each of the pieces of brass. So mark the position of the drill in the work with a felt tip pen. All I have to do now is drill subsequent holes to this line. This is actually the second hole that I drilled, and now I'm going to show the tapping operation. I'm rotating the chuck by hand, and as you can see, the entire lathe is moving. This is because the camera is on the concrete floor, but the lathe is on some very heavy density foam pads sat on the bench. And just to set the record straight, even though the lathe and chip tray is sat on foam pads, it is extremely accurate because there is no twisting of the bed. Once I threaded the hole in the first brass rod to the correct depth, I used a felt tip pen to mark the tap. When I thread the other brass rods, the depth will be the same for all of them. I found some of the simplest solutions not only to be the quickest, but possibly the best. Here's a shot of the first threaded rod. And these are going to be really easy to fit. When the water gauge is fixed in position, it's not very easy to get at. By using this method, it should make it very easy to mount the brass rods into the water gauge in situ. When I measured the distance originally between the two gland nuts with the gauge in position on the engine, it was 4 inches. The piece of glass tubing currently fitted to the water gauge on the bench is 4 inches long, and that's a bit short. I'm going to use this one, which currently has a length of 6 inches. I may need to trim this down a bit. When I fitted the first rod in place, I used a brass slot-headed dome head machine screw. But for the finished job, I think I will use these hexagon bolts because they look a lot better. Once I've finished all of the facing, drilling and tapping operations, I loosely assembled the unit. From this clip, even though everything is not tight, you can see what it's going to look like. Here I'm removing the sharp edge of the glass tubing with a piece of wet to dry sandpaper. But there is a better way. I don't often do it like this, but just for the video, this is another way of removing sharp edges of pieces of glass tubing. It's self-explanatory. I'm using my small Proxxon blowtorch on the bench to melt the end of the tube, which removes the sharp edge. The last job in this episode is to thread one of the brass blocks to accept a 6BA bolt. And here you get the idea. The bolt, or in this case the machine screw, holds the brass block in position at one end of the water gauge. Why didn't I just copy the original water gauge? And the reason is, it is not necessary. I will never need to remove my water gauge to clean the glass. So my logic says, why go to the trouble of making something overcomplicated? Because this one will do the job perfectly. And on that note, I would like to say, stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.